more on the, the properties of matter, physical change and chemical change, like that, and the classification of matter. And let's do the flowchart so that we can easily understand what we have done, right? We will trace that, what we have done, so that we have a clear picture for our learning outcomes or learning objectives, something like that. Because it's not also good. We always focus on the content and we did not calibrate and measure the learning in this interactive way of vlogging, and then in that way also to gauge the effectiveness of how I discussed to you guys, because I found out I'm very fast in talking, and sometimes also somebody cannot understand my language because I talk very fast, and sometimes also they can understand well. It's up to the audience, the type of audiences. Okay, like this. Okay, we will draw the flowchart to make it fair. Okay, para it will be justifiable. Oh, there's a justice of your discussion, what we have done. We have chemistry here, chemistry, and then after that we have matter. Okay, and then the matter, I don't have to define one by one because it's only a rough flowchart, a schematic diagram. And then the matter, the other side, it's really have the molecule, okay, the atom, okay, the mole, on the other side, it will be break, right? And the particles, okay, like that. So I make some, let example one by one. So one molecule of water, okay, one atom of an oxygen gas, because every element is made up of one atom. Okay, like that, something like that. Okay, mole, a basic unit of measure of the amount of substance. Okay, like that. Sikat kayo siya, because we always use this in our balancing equation in chemical reaction to solve what is being asked, the stoichiometric relationship amount, something like that. And the particles is very important also. Why? It gives us light. Okay, because the fluorescent will give a photon particle that gives us light every time, the light energy. And we have the electrons to produce electricity due to the electrons flow. And electrons also are particles. Protons, neutrons, and blah blah blah, name it a lot. So that is under particle. Okay, and then we go to the other side. Okay, this will be now the liquid, the gas, and the solid. And these are all phases of matter. Okay, this is states of matter, and this can also called forms of matter. The three terms can be used interchangeably: form, state, and phase. PHAS. I always emphasize it because we have also our phase here. That is not the FACE, okay? Like that. Maybe my pronunciation is not accurate, but so you can interpret it another way around. Okay? Like that. And after that, okay, we now in the center, we have now the properties of matter. Okay? Like that. Okay? And then we have here the classification of matter. Okay? And then we have here the changes of matter. Okay, changes of matter. Okay, like that. We need to emphasize the changes of matter because it's in here. We have chemical reactions, balancing the chemical equation. So there are a lot of physical changes. There's a lot of chemical changes in a chemical reaction. So the main focus will be here if we study chemistry. Okay, will be here, the changes. Okay, because chemistry, again, over and over again, is a branch of science that deals with the study of matter and the changes it undergoes. So meaning here, we will focus here. Meaning the calculations are here also. A lot. Problem solving, blah blah blah, chuka chuchu. And then the properties of matter and the classification of matters is more on the theories and concepts. Not really requiring a lot of problem solvings and calculations. Okay, properties of matter, physical property and chemical property. Okay, properties of matter. Classification of matter will be pure substance, okay, and mixture. Okay, like that. Combining of elements together, okay, under here. But not necessarily computing the amounts in changes of matter. Only breaking down. For example, water will break into H1O2. That's it only. No need to compute how many oxygen will be ionized or how many oxygen will be produced if you add something blah blah chupa chuchu. Okay, so like this. So it's only mixture. Okay, no changes. Okay, now physical property, extensive property or extrinsic property, and then intrinsic property and intensive property. Okay, and you should know the definition. I already discussed this a while ago. Okay, now you have a pure substance. You also know, I discussed it also, what's the definition that a long time ago. Wow, a long time ago talaga siya. Okay, like that. And the lecture also already also discussed what's the definition for this. Okay, like that, so and so. Now, the pure substance will be break also into elements, okay, like this. Elements and compound, okay, the pure substance. And the elements also will break into metal, non-metal, and metalloids. You get the point? And the compound also will break into inorganic compound and organic compound, in which the study here, we are focusing in the biochemistry, the lipids, the fats, nucleic acids, carbohydrates, sugar, the salts. So it's all about life survival in this contemporary world, in this compound study. Inorganic, not necessarily because only acids, bases, salts, oxides, not really that powerful, because acids can be studied also in organic. It's organic really that made us alive. Protein, carbohydrates, the study of organic chemistry in this biochemistry is very important. So in that, we can manage what diseases will be obtained, if your sugar will be high, like that, if your uric acid will be high, your creatinine will be high, your blood glucose sugar will be high, okay, and you need insulin level to stabilize, okay, like this, okay, insulin hormone, something blah blah, okay. Muna siya diyan nakita. So muna na siya guys ang complete flow chart. Okay, and we already studied that previously, right? Here the theories and concepts. And now we are now here in the calculations in the changes of matter. This topic particularly. That's what I am explaining to you. Okay, so every time I talk, it's coming from the flow chart. Okay, there's a basis why I discuss it in this, in this flow chart. Okay, like that. So we are now in the changes of matter. And then, example of the changes of matter will be the physical change and the chemical change. And the chemical change will be on the chemical reactions. Okay, like that. And then, chemical reactions not only limited to, to the 5 types of chemical reaction, in which we already know also. So we have also the dilution process. Dilution. And then, more on the quantitative chemistry and qualitative. So we have the dilution, we have also the titration, most applied by chemists in the laboratory. Okay, so this is also part of changes in matter study in our overall picture of the study of chemistry dealing with matter in ATTER. Okay, ganun siya. Now I have the problem solving now as an example. I did not solve yet. Because if I don't solve this, then there will be no challenge at all. Okay? So the question goes like this. The first you have to identify, right? At 38.6 milliliters of 0.249 molarity of sodium hydroxide solution was required to completely titrate 44.7 milliliters of a sulfuric acid solution. Acid solution meaning there's water, right? Determine the unknown concentration of the sulfuric acid solution. So basically, this is what? This is quantitative chemistry because amount man siya, concentration. Okay, because the amount is not limiting only to the the mass, the volume, the density. It's also concentration is applied there. Okay? Expression of the concentration. This is not qualitative. Okay? Like that. And now what you will understand here, the process of, it's mentioned, titration. Okay, titrate, say Titrate. So titrate meaning you have to combine different solutions. Okay, by testing it. Okay, so that you can have the solve the unknown concentration. Now we analyze the problem. Okay, the first step. Okay, ganun siya. Okay, we analyze the problem, and actually, guys, you know, this is, as what I remembered also, this is a little bit difficult to the board examination I encountered, because in the board examination I encountered, I remember there's a question like this in the day 2. But you know, it's just in 1v1 is equals to n2v2. No need to have the chemical reaction, but this is more difficult, this one. Okay, but the only feeling, we feel it difficult because it seems that that is a final round in your profession, that you need to pass because I need to do it, so that I will become a licensed engineer, like that. That's only the pressure is in you, your perception and your mentality. But actually, it's not difficult. You know, got the point. It's not, mentality also matters during the actual. It's obviously natural. Okay, especially when you join competitions. Me also before, for example, I'm joining amateur singing contest. I feel also, you know, heartbeat in my, you know, heart. My heart beats too fast. If I see some contestants are very good, something like that, I'm also next to perform. It's just like that. The feeling also, there's a pressure. Though it's not really that difficult, something like the mentality sometimes and the perception, how you attack the particular problems or the particular situation also matters a lot, Okay, so this one is a type of expression of the concentration because it expresses the molarity of the solution. So in this case, you need to remember the word titration and you have to remember the word molarity. And then you have to determine the unknown concentration. So these are the K terms. When you analyze, you need to look the K terms, you know, because these K terms are very, very significant to establish and to extract an appropriate formulas and equations to be used to solve what is being required and asked in the particular problem. Okay, now, given the first step, given, assuming that you have already the K terms in your brain cells. Okay, so given step 1. Okay, ganon. So this is gonna be a spoon feed discussion because I'm treating my audience as grade school level, elementary level, and then high school level, or a little bit of freshman college. I'm not expecting my audience to be, you know, graduates only already or professionals already. No, I'm treating my students are, you know, in the lower level, something like that. Okay. So given data, because you know, professionals, engineers, scientists. Okay, they will be boring to listen this way how to solve because they have done this before so many times in their 4 years, 5 years. So they will find boring to listen well. Okay, but if you discuss this to the young minds, the elementary level, grade 6, grade 5, and then the high school, it will find interest in it because these are the present subjects we are facing nowadays, something like that. And you have to learn a lot, the basic foundations before going to senior college, like that. But not all also, there are also professionals who are interested to this as well. It depends on the kind of mentality and attitude and character of any individual actually. Okay? Something like that. So given the data. When we speak of data, we normally mean the data. Data means a lot because that is the plural of datum. Okay, datum is a singular form and data is a plural form. So there's a lot of datum. English. Okay? Something like that. So data. So a lot. Right? So that's why others also, when they speak in social media, wrong grammar. Okay? Because they don't analyze that the singular form of data is datum. You get the point? The same as analysis and analysis. Okay? The singular is I and the plural is letter E. Analysis. Things like that. Okay? So this is what we called as collective plurality of the terminology, collective. So it will not apply to the basic one. So there's few like this also. Okay, I don't want to teach that because that's English topic. This is not an English vlog. Okay, like that. So data. Okay, I'm not also majoring in English. Disclaimer. Okay, I just know that because I read a lot. Okay, something like this. Okay, data. Okay, 35.6. Okay. Milliliters. Oh, again, the prefixes will come out. Milli, meaning 10 to the negative 3 in the prefix of algebra math. Okay? The one I taught you a while ago, from 10 to the 1 to the 10 to the 18, and 10 to the negative 1 to the negative 18. Milli is a prefix. Okay, to make it shortcut and straightforward to understand. The unit of measure. Okay, like this. And this is SI metric system, or SI units or metric system. Okay, like this. So 35.6 ml of, guys, 0.249 molarity. Okay, of sodium hydroxide. So sodium hydroxide is a strong base, right? Okay, I forgot. Kaloka. Okay, molarity. So when you mean of molarity, capital M, that means very basic in chemistry. That is moles of solute. Okay, okay. This is basic in engineers. Moles of solute over liters of solution. Usually chemical engineers will never forget this. Okay, liter of solution. Okay, like that. So the liter here is the solution. Remember, solution composed of a solute and a solvent. Okay? Like that. The solute would mean not necessarily a solid. Sometimes it's also a liquid. It depends on the situation, especially in the unit operation liquid-liquid extraction. Okay? We combine a lot of liquid substances. For example, benzene, toluene, water, and then there's no solid there. But there's solute for these liquids. So what I emphasize, not all the time the definition of solute is always a liquid. Okay? It depends on that amount relationship. Okay? Stoichiometric amount during the mixing process in that particular unit operation or physical process. Okay? Because most of the unit operations are physical process. Okay? Or physical operations. Okay. Going back to moles of solute per liter of solution. So this will become moles per liter. Okay. Now, as I discussed a while ago, guys, there are two ways of solving the problems. Could it be mathematical and science? We will be able to use the formulas and equations, standard, first. Second, the conversion dimensional analysis, in which we need to have the basis of calculation and we need to cancel, numerator, denominator, like that. That's two ways of solving. Intelligent people, and smart people, and genius people, and who have a high IQ in math, they would rather choose this dimensional analysis rather than the formulas and equations. Most average students, a lot, or below average, and a little bit higher average, they will use the formulas and equations because it's easy to use. Okay? And then, but sometimes, when you forgot, and then you'll be lost. That's why you also know how to derive that formulas and equations. And again, since that is an examination, no need to derive over and over again. It will take you a longer time. So that's why we memorize normally the formulas and equations. Of course, that's why if we need to memorize, we need to understand what we are memorizing so that it will never fail to accumulate in our brain cells. And we could still remember the relationships of those quantities properly. Something like that. Di naman pataka o memorize. Okay, that's my point. Okay, now the second is you have to analyze the paragraph. Okay, titrate 44.7 ml sulfuric acid solution, period. So it's in there that you have to mix because there's already period after the sentence. Kung naikama mo, lahit naman siya ang imong interpretation. Okay? Like that. So, 44.7 milliliter of sulfuric acid is what the unitary area mga given. Okay? 44.7. But honestly, guys, I don't love the dimensional. Okay? I don't love the dimensional solving because magbibong-bayong po, guys. But sige lang. Okay? 44.7 ml of sulfuric acid. Okay? Like that. Okay. Now, you already determined that the molarity is moles per liter, right? And you have to titrate, meaning to say, you need to combine the two, the sodium hydroxide and the H2SO4. So that means that you have to undergo the basic chemical reaction which is known as neutralization reaction. Because this sodium hydroxide is a base, sorry, it's a base. Sulfuric acid, of course, is an acid. So acid plus a base is equals to neutralization reaction to produce a hydrolysis product of salt and water. Okay? And this can be done through the physical operation known as titration. Okay? Like that. Meaning you need to have additive in it, a drops of certain phenolphthalein or whatever. Okay? And you have to add something before you titrate. And the color will change, like that, blah, 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 so and so. If the color will change, that's an indicator that you will stop your titration, like that, right? In the chemical laboratory, in the quantitative chemistry or qualitative, or even in the general chemistry lecture laboratory. It's already there na ang titration method. Okay? Ganon. Now, determine the unknown concentration of sulfuric acid. So we need to determine the capital M of, question mark. Capital M of the sulfuric acid. And then, or the moles per liter of sulfuric acid. Ganon. Now, since you are using the dimensional analysis in here, okay, so you have to start with the basis of calculation. So what is your basis of calculation? Your basis of calculation normally starts what are given. Okay? In this case, go to the complete given, not the incomplete given. Okay? Then if there's no complete given, go to the incomplete given. At least you have that basis of calculation. And if you don't have, that's the time you remember the concepts. For example, at standard temperature and pressure, at room temperature, at ambient temperature. So these are already assumed to be memorized. Okay, at standard pressure you use, because at that certain standard operating temperature and pressure, there's already given physical quantity. For example only, touch a little bit, density of water. Okay, the density of water at standard temperature at 4 degrees Celsius, 4, at 4 degrees Celsius is 1 gram per ml. Okay, 62.43 pounds per cubic feet and 1,000 kilogram per cubic meter, or 1 gram per cc or cubic centimeter, because the milliliter will just be equal to the cc. 1,000 cubic centimeter is also equal to 1,000 milliliters. That's why we can say immediately without question that 1 gram per cc is just equals to 1 grams per ml. Okay, going back to this problem. Okay, so we'll start now with 35.6 ml. Okay, take note guys, we need to convert this to liter. Why? Because our unit of the molarity is liters. It doesn't jive, it doesn't match. You cannot proceed further. Or you can start that in ml and you can also convert that there while you are writing. It's up to you. But for me, when I was a fresh year college, I need to convert that first because para di siya malubog. Okay? That's my style before. Okay? So I need to convert this first in my own style. Anyway, it depends on you what is your comfortability and convenience in doing this. This is only a guide. Okay? Like that. So 35.6 ml, I can see directly that is 0.0356 because we know that 3 zeros will go to the left. Okay? Because that is milli raised to the negative 3. So you have to go to the left and put move 3 places. Then that is 0.0356. No need to show. If you want to show also, then you can. Or you need to divide by 1,000, you can also. Okay? So, this is already, discussed in the grade school level, elementary level, how to convert this type of, right? Okay? So 35.6. Ngunit so na lang dito guys, ha? Okay. So there's a formula for this. Is M1, capital M1, V1 is equals to M2, V2. This is specific formula in which we don't use because we are dimensional analysis conversion. Okay, now, solution using the dimensional analysis or conversion solving problems. So, solution. Okay, so start with 0.0356 liter. So 0.0356 ganon letter. Or let's say you will start with the molarity also. Actually, it's up to you guys. Anyway, it will be cancelled. But I would rather use this molarity because as I say, special. Because there's a denominator. I love it. Wow. But it depends on you, ha? Okay? Makuha naman Japon siya. Okay? But I love the molarity first. Okay? So, 0.249, okay, molarity of sodium hydroxide, okay, that is moles per liter, right? Ganon. Oh. Moles per liter. Now, you have to convert that one, right? Because you have the liter already solved, 0 plus 0.0356 already. So 0.0356, okay, liter of sodium hydroxide. Okay, now the letter will be cancelled, right? Okay, ganon. And we have still the mole of sodium hydroxide. Okay, let's do this in this way. Okay, 0.0356 liter, okay, of sodium hydroxide. Ganon. Okay, sodium hydroxide na itong gipangita ni Aran Hitayo na. Okay, ganon. So, cancel na. And then sodium hydroxide is here. Okay? Now, kung saan mo itong buhaton yung higayo na, because this is a sodium hydroxide liter. Okay, and we have the mole of sodium hydroxide. So, we will base now in a chemical reaction. Okay? Taas-taas ni Rachel. Rachel, kaya pa may chemical reaction. Okay? Nakakalo ka. Di ba sa akong board? I have limited space in my whiteboard. So, ako na ako guys. Okay? Gagmay na akong letters. Okay? Ako sa ibutang akong chemical gamay. Okay, sorry guys ha. I have a very, very small whiteboard. I cannot write everything. Okay? So, how can I do this? Nakita niyo guys? Ako yung papasok ng bang guys? Okay, para madali. Okay? I will erase other data. Okay, so that I can accommodate the chemical reaction. Okay, something like that. Okay. Anyway, you write right. So ganun lang siya. Okay, so I have here sodium hydroxide plus sulfuric acid is equal to, these are both liquid, right? Is equal to, this is double displacement chemical reaction. So this is H2 plus OH is equals to water. Okay, then sulfate plus sodium is equals to a salt. That is sodium sulfate, right? Sodium sulfate, then cross of the charges, it will become Na2. And sulfate has no subscript anymore because it's just equal to positive 1, the charge of sodium. Okay, like this, and then balance the chemical equation. Sodium, okay, 2, okay, oxygen, chararat, hydrogen balance, chararat, sulfur balance, chararat, okay, oxygen, so 2, 6, and then oxygen 4 plus ganon, juba, chuchu, then hydrogen is 2, 4 sha, so 2, so 4 moles, 4 molecules of water, so 4 hydrogen, 2, oxygen is 8, 2, blah blah blah, so and so, 8 hydrogen, 2 ganon sha, juba, chuchu, and then sodium, balance, perfect. Okay, these are balanced chemical reaction. We review this also because if your balance equation will be wrong, you will also undergo a very wrong answer. From here pa lang, i-perfect mo yung daan. Okay, sodium hydroxide 2, sodium hydroxide 2, hydrogen 4, hydrogen 4, oxygen 4, 4, then 8, right? Okay, so oxygen 4, 6, sorry, 4 plus 2, 6. Okay, 6, 6 oxygen balance completely. Okay, assuming na na-balance naman mo siya. Okay, now, how to solve this one? Solution. Okay. Okay, di ba? Ganon-ganon siya. Okay, so we have 0.249 moles per liter of sodium hydroxide, right? And we have also this 0.0356. Convert na talaga siya, ha? 0.356 liter of sodium hydroxide. And then, ganun siya. Cancel, cancel. And this is the mole of the sodium hydroxide. Now, how many moles of sodium hydroxide in the reaction? That is 2 moles of sodium hydroxide. Okay, 2 moles of sodium hydroxide. Now, in the case of the other one, which is the sulfuric acid, okay, the sulfuric acid has 44.7 milliliter, that is 0.0447 liter. And then we don't have the concentration, and we need to find out that one. Okay? So if we have 2 moles of sodium hydroxide in our chemical reaction in in chemical reaction, we do, right? So our partner will be the sulfuric acid. The sulfuric acid here, only 1 mole. So times, okay, ganda lang siya, 1 mole of sulfuric acid. Okay, ganun siya. 1 mole of sulfuric acid over the liter of sulfuric acid. Okay, ganon. So, pila man ang imong liter sa sulfuric acid? O, nana siya kuan, 0.447. So, 0.447 liters na siya. Cancel the mole of sodium hydroxide. Cancel the mole of sodium hydroxide. Like this. And what we left is the moles per liter of sulfuric acid in which our required. Okay? So, moles per liter, it will become N. So, calculator please. Charala. Ganon. Makakaloka. Okay guys, i-calculator sa nila to guys ha. Okay, we start first the denominator. Okay, 2, nakakaloka, 2 times 0.447 is equals to 0.894. Di ko ganahan na ng dimensional guys, oy. 0.894. Di ko komportable. Sige lang. 0.894. Okay. And then the numerator. Okay. Let's check lang dito talaga guys ha. Para we have 2 options. Times 0.0356. Okay. Is equals to divided by 0.894. Okay. So 0.249 mole. Okay, 0.249 times 0.0356. Okay, like that. Okay, and then the other one is 2 mole of sodium hydroxide. So 2 times 0.00447, right? Okay. Okay, perfect. So 0.0894. So, ato pa yung i-divide ang taas. Okay, times 0.0356 divided by is equals to divided by 0.0894. Okay. Memory in. Okay, memory in ta guys. 249. Memory and memory recall. Sorry. Memory recall pala. Okay, divided by 0.0894. It is 0.9. 0.9 molarity of sulfuric acid. Okay. Now, you will think this in this way. If it is correct or not. So you are starting with 0.249 molarity when you combine that. And then why it will become 0.09 molarity of sodium hydroxide? You tend to think, why? And now that's the time you will have to establish the theory versus the concentration and the volume, the relationship. Okay, so in which particular formula to use this one? So let's say for example, concentration C is equals to N over liter, right? And then in the theory of the phase equilibrium, stock knowledge lang siya guys. Okay, so crisscross, it will become concentration times the liter is equal to the number of moles. Now, we try to apply the law of conservation of equilibrium in the phase equilibrium. So, I mean time independent. So we need K was our equilibrium constant. And then we will just say that at equilibrium principle, all your equilibrium constant will be equal. That's why it's called equilibrium. So you say K1 is equals K2. And we let this N as K1. Okay? Since we have two here, the sodium hydroxide and the sulfuric acid. Ako rin siya guys ha, based on my learning. Okay, so we will say K1 is equals to K2. Now we will say concentration of sodium hydroxide plus the liter of sodium hydroxide is just equal to the concentration of sulfuric acid for the volume of the sulfuric acid. So we denote the 1 and 2 means initial and final. So we need to say C1, L1, C2, L2. So this is how we derive the formula I described earlier, that M1 V1 is equals to M2 V2. Only differs in the letters, because this molarity is the concentration C and this V is the letter. It's just the same as long as you know how to derive. Okay? It doesn't matter the letters already, the declaration of the variable. Okay? Now, so if you try to get the relationship, you can never get the relationship if you try to equate that directly. So the best thing is to break the equilibrium constant to 1 K1 and then also the equilibrium constant K2. Now, the K1 here is K1 is equals to CL. If you try to solve for C so that we can determine the proportionality, we can say K1 is equals to L, right? Just to prove that our answer is correct, we need to determine the concept of the relationship of the quantity. Okay, because if you will not understand that one, sige lang kang solve, and then your answer is incorrect already, aside from reviewing that. Okay? Review that mathematically also, but it will take time to review. It's better to know the concept directly. Okay? So, if we increase the concentration, the volume will decrease based on this situation. Now, let's go back to this chemical reaction. Okay. If the volume of 35.6, may taas siya, di ba? Of sodium hydroxide. Now, it will become 44.7. The volume increased. In this concept, the volume increased. So the concentration will decrease. So the concentration starting from 0.249, initially, it will become now 0.09. So our answer is logical and correct. Unless we put wrong numbers in our calculation because nagdali-dali ta, too quick and fast to solve. That is normally my mistakes before. Madali ba? Very quick. So, like, okay, very confident. And then the numbers you put is already wrong. Though you know the concept already, everything, the formulas, but only the numbers you put is wrong. Okay? So that would cause an error. But for the concept, it's okay. You know it. Okay? So this concentration will decrease during the final stage, after titration. Okay? You titrate the two, and then it will become now 0.09 moles per liter, which is correct. Okay? So this is in the relationship of the C1, L1, C2, L2. Now if you use the formulas and equations to solve this, not the conversion, I'll show you. If it is correct, meaning to say, we are solved the same, we have the same answer, meaning our first solution is correct, and it is wrong, then the other option is incorrect. Of course, because it's not matching. Okay, so I will use this one. M1 V1, M2 V2. So that's why I always emphasize that we need to calculate that very well again so that it will be correct technically. Okay? Ganon. Ay, nakakaloka. Okay, M1, V1, M2, V2. But we should be careful guys ha. Molarity kay naman moles dito guys sa chemical reaction. Muna siya sayop ka sa garam guys ha. I think nasayop ko ato. Lagi. Okay, sige lang. Okay, 0.249. Okay, M1 lang siya, diba? Moles per liter. Okay, inabot kay V1 na 0.0356, right? Okay na. Kung ano na siya, liter na. And then M2, atong gipangita, right? Na volume 2 na to, katong 44.7. So, 0.0447 letters. Okay. Masolve na to ang M2, no? Nya, guys, matter na to sa chemical reaction ang moles. Asa mo na ito ibutang? Nakakaloka. So, we need to break this. Kaya siya, i-break na to ang M2 as moles per liter. Ganon. Moles per liter, ganon. Then, the moles of kuan, charangat, the moles of sodium hydroxide, atong balance equation tayo ganina, atong ibutang din sa kili, times na to area para makancel. Okay, ganon. So, muna siyang nakasityat sa mugamit at dito sa M1V1, M1V2, kay mas nindot ang dimensional analysis, right? Okay? But sige lang. At ibalik ang chemical reaction. Okay? Dali ito mag-good. Okay? Though, di ko ganahan, but dali ni siya kung na may number of moles doon sa chemical reaction. Unless lang mag-add-adra ka, di ba? Or may chemical reaction. This is the difficult part in expression of presentation. Sige lang. Okay. So, M1, sarap. Nakakaloka. So, sodium hydroxide, di ba? Like na kung balancing. Nakakaloka. Kung lang ako papasa, guys. Di ba? Nakakaloka. Plus, sodium sulfate. Kung hindi papas, nakakaloka. 2, ganun, chup-chup. Okay? 4, 8. Okay. Balance. Hindi so much. Okay, ang 2 moles of sodium hydroxide is here, ha? Okay. Now, na naman ka 3 moles, guys. Dili are. Okay? Now, kung natay 0.249, okay, natay 2.49 moles, okay, and then we have also 4 per liter. Now, para makancel siya, i-multiply for na ng moles sa sodium hydroxide here. Right? So, 2, right? 2 moles of sodium hydroxide, ganon. Okay? Inaman kayo liter, chuba-chuchu. Muna maabot ko rin ang 0.035 liter. Cancel, chuba-chuchu. Now, M2. Okay? Now, we have this, the other one is, pilaman to, 0.0356 volume, no? 0.0447 siya. Ang ipakita na to ang concentration. So, moles per liter and 0.0447. Okay? Muna siya ang concentration. Okay? Liter, cancel. So what will left is the number of moles. But take note, guys, the moles here is of sulfuric acid is 1. So no need to put the 1 because it was already 1. So as is na siya ng molarity. Kaya kung napa na siya yung mga value ng sulfuric acid, butangan sa ninyo 2, 3, 4, 5, like that. Okay, but wala man siya, as if na nasa more na siya. So, molarity is equal now to the denominator or like this. So, 2, ganon. Okay, and i-divide mo siya. Go. Diba? Yes, sakto. I-divide mo. Asa itong calculator, guys? Nakakaloka. Okay. 0.249. Yes. Okay. May tao na naman siya. Okay. Nakakaloka. Ganun ba yan? Yes. So, 0.249 times 0.0356 is equals to, kami siya. And then, because dash is a kilid, you have to put that in the denominator to solve for the moles per liter. Okay, then we have that one. So, i-divide mo siya something. So, 2 times 0.0447 is equals to, okay, so 0.249 times 0.0356 is equals to divided by, ay nakakalaka, 0.894 is equals to, the same, which are perfect, 0.09, okay, moles per liter, our answer, okay, but be careful guys, ha, okay, dili ni siya pareho atong dito ka na M1V1 is supposed to M2V2. You still have to consider the chemical reaction. Stoichiometric, the number of moles in the stoichiometry. Dili siya pareho atong mga dito ba nga how many water you add after the final. Kaya naman sa dito yung iso dito niya. Wala siya chemical reaction, dili siya pareho. Okay? So, ay pa kumpiyansa. In this case, kung may mga chemical reactions sa dilution problem, under siya sa mixture, no? Classification of matter, then you have to take the number of moles in the stoichiometric relationship, balanced chemical reaction. Because you can understand that, guys, usually two compounds, okay, two compounds, one shot. But then if you say the other one is compound and the other one is element only, so it would be not applicable, something like that. You should think back. Okay, ganun siya. Okay, you got the point. 0.09 is the correct answer for this. Okay, because the conventional and the conversion method is equal, the answer is equal to the formula equation we use. Okay, ganun siya. Okay, guys. Now, I will teach you also to the normality, ha? Normality, guys, nagyan ko siya in 1v1. In 1v1 and 2v2. Normality means, normality is the equivalent weight of solute. Equivalent weight of solute over the molecular weight. Okay? Over the molecular weight. Okay. And then, over pag mo siya sa liter. Okay? Normality. And now, how can you get the the equivalent weight of solute? Okay? The equivalent weight of solute, guys, normality, stock knowledge. Normality is equal to equivalent weight of solute over liters of solution. Equivalent weight of solute will be the molecular weight divided by the ionized, replaceable H plus or the OH negative. Because most of the base have OH and most of the acid have H. So during the chemical reaction, how many electrons are being ionized? So count that one, 2, 3, 4. And you should take that in dividing the molecular weight. Okay, for example, I have the example a while ago, sodium hydroxide. Sodium hydroxide plus H2SO4, right, is equal to water plus sodium sulfate. And now, you are looking for the H. Okay, you're looking for the H. So, ang ma-replace niya is 2, right? Because this H2SO4 man siya. Okay, so 2. So, we need to say, molecular weight of the solute, okay, let's say the H2SO4, pila may molecular weight. So, divided by 2. Ganun siya. Okay? This is the normality of H2SO4. Okay? And then the normality of sodium hydroxide, okay, replaceable H is 1 only. Okay? Like that. Not HOH, sorry, because I quickly correct F, because this is OH man, replaceable minus OH. Sometimes like that, you have to think immediately. So OH, so replaceable OH for sodium hydroxide is only 1, or negative 1, so 1. Okay, so negative 1 is only 1 lang siya. Sulfuric is negative 2. So this is exam 2. Okay, like that. You got the point? So when we speak about replaceable, chupa-chucho, it will never carry out the sign. Or else, it's no longer a chemical reaction. Again, in a chemical reaction, we need to avoid fraction. We need to avoid point something in the coefficient or in the number of moles. And we need to avoid negative sign. There's no such, a negative 3 sodium hydroxide will react to negative 0.5. There's no such thing in chemistry like that. So in this principle, since we know that the replaceable OH is in negative 1, even though that is negative 1, we will use the positive 1. Or else it will become negative if we divide that here. Molecular weight divided by ionized replaceable H or OH. You get the point? So this is hold through in the neutralization reaction. This kind of formula. Okay? Hindi mo lang po na normality lang siya. Again, the liter of solute will be there. Umumatter na siya sa equivalent weight of solute. Ang normality. Now, kung di pa dyan ka makontento, there's another technique. Okay, the other technique, guys, you don't have to get the molecular weight. All you have to do is to take note the molarity. For example, okay, so if you prepare a solution in the laboratory, an aqueous solution of, let us say, 80% of 0.25 molarity of sodium hydroxide, something like that. And you have to prepare that, okay, in the laboratory. Say you are a laboratory technician, something like that, or a laboratory analyst, something like this. Okay, now, if you have, for example, a 0.5 molar of sodium hydroxide, okay, let's say at 85% by volume, ganon, chupa-chucho, okay? So, klaro kayo, by volume. So, percentage, volume solute over volume solution times 100, like that. So, no need to another topic, right? No need to discuss. Okay? So, let's say I will never put 85% by volume. Okay? Only the concentration. Okay? Okay, mo add man siya complexity, right? Okay. So, 0.5 molarity of sodium. How can we get, at this value, how can we get the normality? Okay? It's in here that you will multiply immediately. Okay? 0.5 times the replaceable OH. So it will become 0.5 normality also. In case of there's only one replaceable OH will ionize in the aqueous solution after mixing the two concentrations of H2SO4 and NaOH. Now, that is for the base. Now, for sulfuric acid, you have say 0.3 molarity of H2SO4. Now, if you completely ionize that in the water, in aqueous solution, okay, it will never be same with the sodium hydroxide. There will be a H ion of positive 2 will be replaceable because there's a presence of 2 subscript here. Okay, so positive 1 times 2 is equals to 2, right? Ganon. So, 0.3 times 2 is equals to 0.6 normality, diretso. Okay? Like that. Because it will also happen in the board examination that the given are all molarity. Okay? Then if you have no idea, you will go to the equivalent weight of blah blah blah, and that is more difficult to consider because you need to put the reaction like this, blah blah blah, so and so. And if you will be wrong in the charges, then yabo. Okay, whereas knowing this fact like this is very easy to understand. Okay, like that. So if you have given the polarity, bingo, you can get the normality. Meaning to say, normality is directly dependent to molarity. Okay, because there's a liter in the denominator in the relationship. And normality also is a concentration. Okay? So it will become also like this in the derivation, right? C1, L1 is equals to K1, but in here, the C1 is just a normality. Okay, like that. So the same principle, all you have to do is to multiply the replaceable OH ion and the H ion. When it combine, when it react with each other, because of course, it will not react, it will not replace the OH and the H of the sulfuric and the OH of sodium hydroxide, common sense, right? So it will never be ionized unless you will mix them. Okay, you get the point. Ang mga siya natabo. Okay, now kung kato siya na question, kani siya, irambol-rambol na yung isa board exam. Ano din siya? 35.6 milliliter of 0.249 molar, normal, capital N, of sodium hydrogen solution was required to completely titrate 44.7 ml of a sulfuric acid. What is the normality of sulfuric acid? So normally, maglibog na yun, kaya isagol nga molarity. Okay? Nasa isagol na normality. So you should know the concept of normality before proceeding. Things like that. Okay? Because it asks the normality. Because guys, if you solve in terms of molarity, and then you have the answer, let's say, in this problem, it's 109, and then later you will convert that to normality, that's wrong. Okay? You only convert after the final answer. That will hold true only, guys, if that is not concentration chemical equation problem. Okay? For example, mga conversion lang, from mass to volume, from feet to meter, like that lang ba, mga simple na metric system conversion, it will hold through, it will be correct. But in here, it will never be happening because there are a lot of quantities, normality, molarity, volume, like that. And you can never do also here ratio and proportion. Okay? In this type of question. Okay, and you can never do also interpolation in this manner because this is not a graphical representation or tables. How can you interpolate? There are no data given. Okay, so things like that is requires analysis for this. Ha? Okay, then again, iusbo na po din siya. Ano niya? What is the universal gas constant? Nakalimutan talaga, no? Okay, assume that the solution is an ideal solution. Oh, now if you assume the ideal solution, it will behave now like an ideal gas. You get the point? And you will also use the PV is equals to nRT so that you can always get the universal gas type by getting first the value in this problem. And then most of the students, including me, will be also shocked because this is not mixed in our classroom instruction before. Because the examination is just very easy. It based only what they discussed. And then they give the exams, they will try to introduce something new in which they did not discuss, but it's related. Okay, meaning to say, they let the students explore more apart from the examples, or they let them to learn more to explore out from the backs, not only in the classroom instruction. It teaches us to have our own initiative, okay, to expand more our knowledge, not to be dependent with them. So that's the very, very good also challenge for the teachers to the students. But sometimes the students cannot understand that, purpose. Okay, that's why they will say that the instructors are terrors or very strict. But actually, the purpose is very good. Really, they give difficult exams in order for you to study very well. Okay, in order for you to learn outside from the box, you go farther. You go to the library and study more. So there's an advantage, right? Compared to very spoon feeding and the same exams they will give. Normally, they will give an exams that are not purely related so that the students will think and they can understand very well by using their comprehensive analysis in the particular topic. And kaya yung uban, maglagot man ilang instructors are terrors, ganon. But for me, it's quite good. Okay? Like that. To challenge yourself. Okay, ganon. So things like this also, sometimes gonna guys, nga yung sinugdanan. Dahil mukalit lang pangita o kuhan guys, what is the viscosity? Layo ro ba kayo naman? Viscosity, dito ro ba nasa mga heat transfer? Really? And then, gisabulan siya mga pang general chemistry lecture na question. You got the point? So, muna yung makalisod sa problem solving, especially sa chemical engineering, kaya mukalit lang ang mga na-pass na mga topic niya, isagol dito sa mga kuan, di ba nakakaloka? Usay mo sagol ang thermo sa kuan, molarity, usay mo sagol ang basta heat transfer to mass transfer, mo sagol mo diri sa expression of concentration sa colligative property. Usually ba makalimtan na ba yan nato ang mga past sa chemistry sa general lecture. So, mao din na siya purpose ani kanina that we should, that's why that's prerequisites because magamit siya sa atong second year, third year, fourth year, fifth year. So that comprises our basic foundation and it will be used all the time. Ganon. Without fading in our brain cells. Okay. Thank you so much, everybody. Question, you can like and comment and share, whatever. Okay. Bye-bye, God bless everybody. See you later. Babush! Di ba nakakaloka?